So scatter plots. So a scatter plots are graphs that use points to display relationships between two sets of numerical data. And can be useful for observing trends, patterns, or an association. Between two variables. That's important. The fact that this deals with two variables. Sorry about that. I like this purple, but it just colors too dark. If the overall shape of the data resembles a line, and this is important, resembles a line. Sometimes you're going to look at this and you're going to say, this doesn't even look like a line. So it says, if the overall shape of the data resembles a line, the association described is linear. Okay. So below here we have three types of scatter plots. Okay. So there's three types of what we call associations. And two of them we're really interested in. The third one, not so much. Okay. So this is where you collect some data. So as you can see here, you see, and this is a typical one, you'll always see it. I always see it in every single one. Hours studied and exam score. This is a classic one. And this is called a positive association. This is positive. And the reason it's positive is as the value of x increases, so as the values of x increases, we go further along the x-axis. What happens to, in general, what happens to the points as we go along the y-axis going up? Yes. And in general, would you agree that it tends to go upwards? It's increasing. So as the value of x increases, the value of y increases. So when that happens, if you see in general, the trend of the points is to go uphill, that's a positive association. Okay? And in general, what they're trying to tell you here is the more you study, in general, your score on the test should go up or down? Up. Okay? All right. We could also have a negative association, guys. So this one has a trend that's downwards. Yes, it's decreasing. So as the value of x increases, the value of y decreases. So what do we have here? Snow cone sales and sweater sales. two things you would think don't have any connection, right? So as the number of sales for snow cones increases, what can you say happens to the number of sales for sweaters? Bless you. So as the number of sales for snow cones increase, the number of sales for the sweaters decrease, right? Yeah. Because usually if snow cone sales increase, that means the weather's getting hotter. So there's less of a demand for sweaters. Okay. Then the final one, the one that we really aren't too interested in, is when there's no association. When the two pieces of data have nothing connected. So this is going to happen. The change in one variable has no effect on the other. So here's an example. A person's age and what's this? Pairs of socks on. Right? So as people get older, the number of pairs of socks really has no connection to your age, basically. So there's no association, no connection there. Okay? Unless you're a sock collector. Ah, that would be an outlier. An outlier, okay. An outlier would be something that's outside of that connection. Okay, so let's say for some reason, in some location, they really like snow cones and they really like sweaters. So even in the winter, they buy snow cones. Say you have one point that's way up here. They buy a lot of snow cones and they buy a lot of sweaters. This is what's called an outlier. So that's something outside the normal trend. The normal trend is this. Something that's outside that trend is an outlier. So, yes.
When we're looking at our mean, there's this one number that doesn't fit in. When looking at the rest, I forgot what it was
Oh,
called.
mean, median, and mode?
Yeah, when we're looking at our numbers and one's like greatly lower or greatly higher.
Yeah, that might be an outlier. That's a good way to describe it. Okay, let's talk about causation. So write the word causation here. So causation exists between two variables when the change in one variable causes the change in another variable. Describe which scatter plot above describes causation. Okay. So we're going to do that here. So we're going to read these situations in the table, and we're going to decide what type of association. Is it a positive, negative, or no association? Okay. And also, does one thing cause another? So it says for each pair of variables in the table below, describe the association and whether you expect there to be a causation between the variables. If there's something connected between them. Okay? So let's take a look at this first one. A. Go ahead and read it. As the number of cars in a restaurant parking lot increases, the number of available seats inside the restaurant decreases. Okay? So as the number of cars in a restaurant increases, there's more cars in the parking lot. The number of available seats decreases. Would you say that would be a positive association, a negative association, or there's no connection, no association? What do you think? So as one increases,
Number of people.
One decreases.
one decreases. So that would be, now, let's talk about causation. Does one cause the other?
Yeah.
Do you think that one of these causes the other to happen? Does it make sense that one would cause the other? Yes, absolutely.
Yeah.
There is a causation. More cars in the parking lot for that restaurant would mean there's less available places inside. Okay? So try that on the next one. Read it and decide positive, negative, or none, and is there a causation? So here we have one where both things increase, right? As your height each year since birth increases, the average annual price of gas increases, which is true, by the way. When you were little, gas wasn't as expensive. As you've grown taller, yeah. So would this be a positive or negative one? This is positive. Now, does one cause the other? Does the fact that you're growing taller mean that is that causing the gas to go up? No, that's just time going by, right? Inflation and all that. So sometimes you can have some sort of association, but they're not related. They're not connected. Okay. All right. So both scatter plots at the right display positive association. If you notice, the trend is upwards. Okay, we haven't talked about it, but predict which has stronger association and explain your thinking. So you have scatterplot A and scatterplot B. Which one do you think has, without learning what this is, which one do you think has a stronger association? A or B? A or B? I'm hearing a lot of B's. I would agree. What makes you think that B has a stronger association? Brandon?
It's like concentrated in like one area, so it looks more like a line.
I like how you said that, concentrated. I've never heard it described that way, but it describes it personally. Not personally, excellently. Basically, you could say concentrated. The points are tighter together, right? You see that they're closer together? The closer together the points are, the closer to forming a nice line, basically, that makes it a stronger association. So answer however you like here. You could use the word concentrated, thanks Brandon, or however you like. It's basically something like this. B because the points are closer together, more concentrated. Basically, the points are closer and the graph is closer to what shape?
line.
A line. I'll go with that. Okay. All right. So, time to flip the page. Now, this association can also be referred to as what we call a correlation. And basically, what that means is the more the points are spread or scattered, the weaker the linear correlation is. I'm going to highlight that. That's pretty important. The more the points are spread, we also say that they're scattered, the weaker the linear correlation is. In other words, the closer they are to forming a nice line, the stronger the correlation is. Okay? So when they are tighter together and they form the shape of a line, we say that it has a strong or stronger correlation. Okay? So in math, we like to give everything a number. So in statistics, whenever the scatter plot is tighter together, forming a nicer line, we give it a number from what's called a correlation coefficient. So that's what we're going to talk about next. So the correlation coefficient, known as R, so that's the letter R, is a value between -1 and +1. And it's used to measure the direction and strength of a scatter plot line, or a scatter plot. Okay, think about what types of numbers are between -1 and +1. Think about that. Just between 1 and 0, what kind of numbers are there? Decimals, fractions. How about between 0 and -1? Negative decimals, negative fractions. So most of these numbers that we're going to look at in this correlation coefficient, well, there'll be some number between 0 and either -1 or +1. So there'll be decimal usually. And that number will tell us basically how strong or weak and in what direction that line is going. Okay? So here we got a number line. And it goes from -1 to 1 and 0 in between. Okay? So basically, let's do the positive side, because what numbers would be around here? Yeah. If we make this about 0.5, anything between 0 and 0.5, more or less, that would be a weak positive. Meaning, it's weak positive. So if this value for R is between 0 and 0.5, what that's telling me is the line is going uphill, right? It's going uphill, but the points are kind of spread out. Okay? Now, if it's between 0.5 and 1, like a 0.7, 0.8, 0.9, something like that, that would be a strong positive. So meaning the line would be going uphill. It would be positive. And how about the points? What can we say about the points? How are they packed? Tightly or not so tight? They're concentrated, yeah. Though that would be doing that. Okay. So that's on the positive end. If you're over here, this is negative 0.5, right? This is negative 0.5. So if you're here, this is known as weak negative. Weak negative. So that tells me this line, the points on this line, they're going downhill. That's a negative correlation. And they're spread out. The points are spread out. So now if you're here, like a negative 0.8, negative 0.7, somewhere in there, this would be, well, there's only one last option. What would this be? Strong negative. Strong meaning the points are pretty concentrated, but it's going downhill. They're packed. Okay? So here's a little challenge. Here you have these four correlations. 0.2, 0.8, negative 0.9, negative 0.5. Underneath here, write each one of these, match up these correlations with those points. So I'll give you that challenge. I'll give you a few minutes. So figure out where 0.2 is, where 0.8 goes. What do you think? By the way, this is going to be part of your part of what you're going to do on an IXL. So what I like to do is first decide, is it positive or negative? So this one is negative, and then is it strong or weak? Yeah, it's a kind of on the weaker end compared to the other one, especially. So do I want to go with negative 0.9 or negative 0.5? What is this one going to be, guys? Well, compare it to the other one, though. Look at the two that are negative. You want the negative 0.9 to be the one that's a little more tightly packed. Yeah. This looks like a negative 0.5 compared to this one. So this would make this one negative 0.9. Now let's look at the two that are positive. You want the one that's more spread out to be the smaller number. So what do I want for this one? Well, compare it to this, though. Look at this, compare it to that. This one's more spread out. So I would say this is 0.2. More spread out, but positive. And this is a little more compact and also positive. So this would be 0.8. How are we doing? You think you got that? So that's the general idea. The more tightly packed, your number should be over here or over here, depending on if it's going downhill or uphill. The less tightly packed, you want to be here or here, depending on if it's downhill or uphill. Okay. So something you are going to be doing is calculating these numbers. Now, I'll tell you now that there are calculators that does calculate that give you this data, but this one won't do it. Okay, you probably need a fancy scientific calculator more than this, or thank you internet, we have the internet. So there are correlation calculators on the internet. It says use technology to answer each question, meaning the formula to figure out these correlations are nasty and difficult. So we're not going to do it that way. We're just going to plug it in. So let's do it. It says the table shows the number of times theater students practice their lines the night before a rehearsal, and the number of mistakes each student made during rehearsal. So let's see. This is how many times they practiced and how many mistakes they made. Okay. So obviously, the more you practice, what can we say about the number of mistakes? Just from looking at some numbers. They practiced, is this in minutes or what? It doesn't say. Well, 10 gave you 1, 2 gave you 4, 8 gave you, yeah. So let's see what that does. So the way we're going to figure this out is I'm going to go to this, and you're going to do this on your own. Just I want to show you where it is. You're going to go to this correlation calculator, and I'm going to put in the numbers for practices here. And you 6, and then I got those numbers, and I'm going to put the numbers for mistakes here. So there I want 1. What else? 4. Another 1. 2. 3. Oh, 0. And another 1. Okay. And then I'm going to hit calculate, and there is my number. I'm going to round it to the nearest. They want us to round it to the nearest hundredth. So negative 0.93. Negative 0.93. So I'm going to go back to my so this is R equals negative 0.93. Okay. So that how would we describe this? Strong or weak? Strong. Positive or negative? Okay, so now we get an idea, if we were to plot these points, how they would look. Would they be going uphill or downhill? Downhill, because it's negative. Would they be tightly packed or less tightly packed? Tightly packed, pretty tightly packed actually. Okay, so go ahead and it would be strong, negative, correlation, okay. let's do the other one. Number 2, Principal Thomas recorded the number of students at his school who were members of the robotics club and the photography club each year, since the clubs both began in 2012. Okay, so number of people in the robotics, number of people in the photography club. I'm just going to give you the correlation number. But you would enter it into the website there. This one is strong. Also, it's on the strong end, right? Because it's more than 0.5.
Strong positive.
Okay. So in general, the more people that were in one club, the more people there tended to be in the other club. Okay, so the last thing, do either of the tables above represent causation? Okay, does one cause the other? So we got number 1 here, number 2. Definitely not number 2, right? One doesn't cause the other. How about practicing and mistakes? Yes.
I think it's like sometimes the more practices, the more you're open to making mistakes, or like when you practice the less.
Yeah, the more
You work like
hopefully the more you practice, the less mistakes you tend to make. Yeah, one does cause the other in that one. So number 1. And you would basically say that the more you practice, the less mistakes you tend to make. Okay. All right. So this is what we're going to be working on today, guys. I will get you the glue sticks in a little bit. I just want to show you what the IXLs look like. So leave your notes out. You will want them. Keep them handy there.